throughout the semester, and maybe even throughout the rest of your careers, you'll be thinking about these 13 recurring themes. Okay? At any given moment, some of these themes might be irrelevant, but over time, you'll see that these themes will tend to recur. I've alluded to some of them already. The first one is experimental versus non-experimental designs. We'll be talking about what makes it a pure experiment, and what are some quasi-experiments or false experiments, some pseudo-experiments. We'll be talking about that and what kinds of information can be gleaned from each of those different kinds of designs. By now, hopefully you know all about independent variables versus dependent variables. Okay, independent versus dependent. Typically on a graph, we plot the independent variable on the x-axis, and on the y-axis or vertical axis, we plot the dependent variable. We sometimes have these special words for the x and y axes. We call the x-axis the abscissa, and the y-axis the ordinate. Okay? So that's typically how we plot these things. We'll be looking at similarities versus differences. When we're talking about similarities, we're thinking about how some variables might change together, or how they might co-vary, sometimes positively, sometimes negatively. But in any case, we'll be looking for similarities or correlations. Some of you might remember working with the R statistic in Intro to Psychology. Other times, we'll be looking at analyses where we'll be comparing difference scores, the difference between one group's score and another group's score. Or maybe we'll be looking at how you performed and your cohorts performed in one condition versus how that same group of people performed in a different condition. So we'll be looking at differences here, maybe by way of a t-test, maybe by way of ANOVA. If you haven't heard those terms before, you shouldn't feel bad about that. Okay? We'll be thinking about central tendency versus dispersion. Here I'll ask you to stop the video and see if you can name 3 different types of central tendency in a data set. One hint for you would be that they all begin with an M. So you can stop the video now and see if you can name the 3 measures of central tendency that all start with an M. Okay, welcome back. And those 3 measures, as you might recall, are mode, median, and mean. Whenever we have a data set, we can talk about the mode, median, and mean. We can also talk about how the scores are dispersed or spread out around that measure of central tendency. And there are different indicators of dispersion. One of them might be something like the standard deviation, the average extent to which the scores depart from the mean. You might have a range of scores. You might say that the lowest score was this, and the highest score was of that value. You might talk about some central ranges. You might say that the 25th percentile of this distribution is of a certain value, and the 75th percentile is of another value. We might call that an interquartile range. I don't expect that you've heard of that before. And then we might have other measures that we can think of, such things as confidence intervals or standard errors of the mean. Lots of different ways of talking about how the scores are dispersed, and the capacity to understand dispersion very well is largely what separates high school reasoning, which tends to emphasize central tendency, versus college-level reasoning, which tends to understand how the scores are dispersed around some measure of central tendency. We can also talk in our course about significant effects versus chance or random effects. And to do that, we'll be introducing a little bit of probability theory. We'll be talking about different kinds of ways that we can measure our variables, our dependent variable and our independent variable. Those can be measured on different kinds of scales. Very briefly, I'll name them here, but I won't go into detail about what they are. Just in case you want to jot them down, there is the nominal scale, which is also called a categorical scale. And that's the crudest kind of scale we can have. The next most refined kind of scale is called a ordinal scale. So nominal categorical first, ordinal scale is second, and then finally something called a interval scale. Okay? An interval scale actually has another component which we might call a ratio scale, and we'll talk about that too. In SPSS, we put interval scales and ratio scales together. So the point for today is that you have many different kinds of measurement scales. And we use these measurement scales to pull out information about variables, and we frequently want to know how those variables might be plotted on a graph. We sometimes call these graphs frequency distributions, and we're going to learn about different kinds of frequency distributions. The one that's maybe most famous is the bell-shaped curve, and we sometimes simply call it a bell curve. It's also called occasionally a normal curve, and it's sometimes called a Gaussian curve, after the mathematician Gauss, who founded that curve and the mathematical formula that underlies that bell-shaped curve. On any frequency distribution, like a bell-shaped curve, we typically have the variable of interest on the x-axis, and then we have frequency on the y-axis. Again, the x-axis we call the abscissa, the y-axis we call the ordinate. Yeah? We'll also be talking this semester, we're up to number 8 now, about descriptive statistics, where we're simply giving the means and the standard deviation or some indication of central tendency and dispersion of a data set. Or we'll talk about inferential statistics, a big word here. When we're talking about inferential statistics, the root of this word is inference. And when we're describing an inference, we're talking about drawing a conclusion or an inference about a population from a small sample. And we'll have some statistical ways of doing that that will involve p-values or probability values that you might remember from Intro to Psych, and we'll engage in some hypothesis testing there. Whenever we do that, and we're drawing these conclusions, sometimes we get it right, and sometimes we make errors. And we'll talk about 2 different kinds of errors that we have. We call these type 1 and type 2 errors. Essentially, these are false positives and false negatives that can be realized in any kind of experiment. We'll talk about some of the issues that we have relating to statistical power, which is the capacity to find an effect if it's there, the capacity to basically avoid a type 2 error, a false negative. So different kinds of errors that we're going to be learning about. I think you'll find that to be very interesting. Here we are on our last substantive slide, and we're up to number 10 already. We'll talk about the difference between subject designs and within subject designs. I won't say more about that here other than you almost certainly had exposure to that in Intro to Psych. So we'll be revisiting that, and during the semester we'll have you design experiments and other kinds of studies that are of each of these varieties so that you have a broad array of tools to work with. Okay, we can talk about number 11 as well, single factor designs versus quote-unquote factorial or multi-factor designs. On this bullet item, the word factor corresponds to an independent variable. Many of the studies we'll talk about in this semester have a single independent variable. We call that a single factor design. But we could have 2 or even more than 2 independent variables, which is to say we can have multiple independent variables or multiple factors. We call that a factorial design. There are some complications that arise there, but we'll work with those when we come to them later in the semester. Just a note about that, we will not be dealing with the case where we have more than one dependent variable on the y-axis. We'll only be working with a single dependent variable throughout the semester. We'll look at various examples of those. If you take an advanced course on statistics, you'll be able to see that we have multivariate statistics, which help you with multiple dependent variables on your y-axis. But now in this course we'll just do a single factor design, one independent variable, and then a little bit later on more than one independent variable, always with one dependent variable. We'll be talking about issues of reliability and validity. Okay? Important components of our research methods. Are we consistently measuring what we believe that we're measuring, and to what extent are we measuring what we think we're measuring? Or do we have some mismatch between our concept and what's going on out there in the real world? Okay? Okay, lastly, I'll leave you with this. I hope this is a bullet item that calms you a little bit. Many students have anxiety about taking a research methods course because they know it involves some mathematics. It does involve some mathematics, but the mathematics can almost always be reduced to something you learned about in 4th grade, a ratio, where we have a numerator up top, we have that line in the middle that shows us we're going to be dividing by the denominator, which is down on the bottom. As the course goes on, I might show you some fairly complicated looking formulas, but I assure you, all of those can be reduced to very simple ratios, numerator over denominator. And if we keep that in mind, we'll be able to understand conceptually what's going on in what otherwise looks to be like a complicated computation, but it really won't be that bad. It's all about ratios, ratios, ratios. Let's make that our mantra for today. Say it with me. Ratios, ratios, ratios. Okay, great. All right, so that's where we are. Congratulations on making it through your first video, and I look forward to seeing you in class.